And the Sydney winner is 4 hours 15 and 5 miles.
Start lever.
Start lever off.
Engine AC. Check on
Destination
3.
91.
No damper.
30 at 4 with 5 miles.
On the green light.
And we're using
Phase 2.
the Emil
Check this
as an alternate.
All makes a cancel call.
Round the back, Billy.
For centuries, the stagecoach permitted the privileged few to make long, dusty, and weary journeys, often taking weeks for the traveler to reach his destination. Aside from the drivers, the stage operation was usually handled by one man, the dispatcher, whose responsibility was to organize the change of horses, the sale of tickets, to see to the maintenance of equipment, communicate with the stations along the route, and to calculate the fuel consumption, which was then oats and hay. Pre-planning, equipment servicing, crew scheduling, cargo and baggage handling, passenger accommodation, en route maintenance, relief crewing are some of the problems that have been carried over from the operation of a stagecoach line into present-day air transport. En route maintenance was provided by the blacksmith, whose skillful blows shaped the replacement parts when needed. It is an awesome thought to contemplate that from this scene to this scene is only slightly more than 100 years, and is cause to speculate on the degree of comparison that will exist between today and 100 years from now in the field of transportation. The heart and soul of an airline are the people who operate it. The activity that takes place in this administration building, which houses the operational department of Qantas Airways, controls the complex services required in present-day operations. Here, we have thousands of people performing specialized jobs. Training of technical flight crews is by itself an enormous task and expense. And of course, we are familiar with the more tea, madam training of the cabin crew. But there are all the other members of the airline family whose specialization needs specialized training as well. To set up ground services over an international route structure is an extremely intricate task for any airline to undertake, especially when this route structure at times takes the airline's equipment around the globe. Here at Kingsford Smith Airport in Australia, we have an example of a Royal Dutch Airlines jet aircraft being serviced by Qantas Airways ground service equipment and personnel. This is typical of arrangements that are made between airlines in order to get maximum use out of expensive ground service equipment. How efficiency is achieved is no accident, and the activity that we are seeing is the end product of advanced planning. Planners are at work continuously to prepare for the next generation of aircraft. It is not only new types of aircraft, but also new concepts in aerodrome design, which have to be incorporated into planning. The manner in which aircraft are fueled, provisioned, and loaded with cargo and passengers must be carried out with the utmost efficiency and precision in order for an airline to get maximum utilization from its aircraft. And the degree of effective utilization, as in any business, is the difference between success and failure. The passenger is probably the most unpredictable element with which an airline has to contend. He has many requirements which have to be satisfied. The problem of making connections, confirmation of space, documentation for international travel, and his well-being have to be continuously catered to. Behind the staff at this bustling check-in counter is the traffic office. Teams work in pairs to handle the paperwork of the many flights that depart each day. This position is manned by the scribe, whose function is to sort tickets and arrange seat positions so that families or couples will be seated together. He compares the number of seats that have been filled against the reservations indicated on this manifest. The manifest, along with information concerning special passenger requirements, will be flashed ahead to stops en route for their information. To the left of the scribe, the load sheet officer takes into consideration all elements relating to the safe takeoff and landing weight of the aircraft. The loading officer reports to the load sheet officer to sign for the aircraft loading sheet, from which he will supervise the proper loading of the aircraft. This sheet is designed to arrange for the correct positioning of cargo, mail, and baggage in the 4 holds. The amount of cargo which can be carried has to be determined in relation to weight of passengers and fuel load. The load sheet officer is constantly assessing this situation as the departure time approaches. There are many activities which are occurring simultaneously at various points around the aerodrome in anticipation of an aircraft's departure. Material is also being prepared by the meteorological service personnel. While low-level weather charts are plotted in this office, other information has been prepared at the weather office in Melbourne. Computer plotting of isobars for required flight levels is fed through on facsimile receiver equipment such as this. The flight forecast form, which has been prepared from an analysis of the various data required, as in this case for Flight 580, is being transmitted by the operator to flight service in the administration building. This flight forecast form contains temperature and wind factors for a choice of flight levels along a sector. Information will be extracted from the sheet to be fed into the computer. A check is made with the traffic office, where we have seen the load sheet officer preparing weights and balances for this flight.
Flight service here. Can I have the weights on the 580, please? Right, 174,500 pounds, POB 98. Thank you very much.
The flight service officer also prepares the computer flight plan request form. This form is designed to be a precise guide in the preparation of data to be programmed for Flight 580. The card punch operator then prepares certain new cards as required for each flight. The new cards, along with existing card stacks, are made ready for the computer. Additional information is stored on tapes, which have to be selected to correspond to a particular route. For international flights, the flight crew is required to report for duty 1.5 hours before a scheduled departure. The flight service officer will brief them from a meteorological form, as well as from the flight plan.
Andy,
0. Here's your weather,
thank you.
and here's the computer flight plan.
Flight plan, good. Sydney weather is forecast to be fine for the rest of the day. Destination Nandi, it's also okay, and using New Mia as an alternate.
Affirmative.
And variable at 25 miles. Okay, planned at flight level 370,
370, got it.
37,000 feet in the upper wings.
Off the jet stream.
And en route weather after that, quite fine, eh?
Yes, there's nothing forecast above your
And
flight level.
at Nandi, the ILS operative, all aids
Affirmative,
clean?
Captain. All aids are serviceable.
And do we have any restrictions on our takeoff weight?
Negative. With your minimum fuel uplift, your all-up weight will be 254,000, and your restriction is based on landing weights, and there's no restriction there. 300,000 is your maximum takeoff weight. So
We could have excess, so quite a 40,000 alternate, total of 70,150.
yes, you can take another 50,000, of course, Captain, if you so.
No,
wish.
Cargo has rapidly moved from a position of relative insignificance to become the fastest growing commodity from which an airline can realize its revenue. The cargo capacity of this Boeing 707 is approximately 12,800 kilograms, or 14 tons in the 4 holds. The carriage of mail has also continued to grow since the very earliest days of aviation, and forecasts predict a continuous growth along with the increase in other categories of cargo. The loading officer, as we saw, having signed for the load sheet, now supervises the loading of baggage, mail, and cargo. He determines that the weight is properly distributed in the various holds of the aircraft. At the same time, he must consider the sectors over which the aircraft will fly and arrange the load in such a fashion that at the next station the baggage and cargo will be conveniently available for unloading. And of course, the load is arranged in a similar fashion for other stops along the route. Fuel is the most vital commodity loaded aboard any aircraft. Its calculation is important for 2 reasons. On the one hand, the main consideration is for the safety of the flight. To provide for safety, it is necessary that sufficient fuel be loaded to allow for the amount of taxiing, wind and temperature along a route sector, holding time at the terminal aerodrome, as well as sufficient fuel to fly to an alternate aerodrome. On the other hand, for an aircraft to carry excess fuel, the profit-making aspiration of an operator can be seriously undermined, since one is not talking in terms of a few gallons, but of thousands of pounds of fuel. We might just examine the fuel requirement for this flight between Sydney and Nandi. First, we have a course composition requiring 40,400 pounds of fuel. Fuel to take the aircraft to an alternate aerodrome, should it be required, 18,750 pounds. A contingency fuel allowance of 7.5%, 4,450 pounds. Holding at alternate reserve, 4,550 pounds. Fuel for an instrument approach, 2,000 pounds. The fuel load, then, for this aircraft is 70,150 pounds, about 1/2 the total fuel capacity for a Boeing 707 Model 338B. Fuel loading, as a rule, is continued until approximately 20 minutes before scheduled departure time. At such time, the fuel hoses are disconnected and the equipment withdrawn from the area. Passengers are boarded until approximately 5 minutes before the aircraft is pushed back. Technically, the last person aboard an aircraft is the load sheet officer, who presents the load sheet calculation to the captain for his examination, and from which he will adjust the stabilizer trim for the aircraft. It is extremely difficult for the load sheet officer to determine the amount of cargo which can be loaded when there are such factors as number of passengers to be carried, amount of fuel required, runway length available, temperature, and wind velocity to be considered. Since some of these factors are constantly changing until the time when the flight is to be closed for departure, the load sheet officer is kept busy calculating and recalculating to arrive at the amount of cargo which can be allowed aboard this flight. In fact, conditions continue to change as the aircraft taxis to take its position for takeoff. Wind could be dropping in speed or changing direction. Temperature could be rising. A main runway could become blocked. These, then, have been some of the considerations in preparing an aircraft for flight, but they are only a very small portion of the overall story. A very difficult problem with which airlines have to contend is the rostering of crews for flights, and especially so with an airline whose route structure encompasses the globe. 40 staff members deal with rostering activities in this department. Crew schedulers constantly monitor the positions and movements of crews around the world. When a flight is not covered because of some disruption, crew schedulers immediately come into action to select a crew to protect the flight. In his selection, the crew scheduler must consider such items as the pilot's aircraft qualification, route qualification, and recency on the aircraft type. This airline schedules its pilots in accordance with a comprehensive agreement, in essence, a bidding system. This system permits pilots to bid for the work they wish to do, rather than be rostered for duties without knowledge of their preference. The staff members here are preparing crew schedules. While in this area, the staff members are working on air crew planning. The administration of approximately 800 technical crew members requires skill in rostering personnel in relation to the routes for which they have bid, consideration of seniority, the necessity of providing coverage for sickness, vacation, training, and extra flying. The complexity of arranging for crews to fly their aircraft is matched by the complexity of arranging to have aircraft available to be flown. This aircraft has about 10 million pieces, which combine to make parts having different life expectancy characteristics, all of which makes the programming of maintenance very difficult. The aircraft is brought into the hangar for one of the many phases of its block time overhaul program. Seldom does an airline enjoy the luxury of having extra jet aircraft standing by, and because of this, complex systems are necessary to control aircraft movement and maintenance programming to achieve full utilization of aircraft. The engineering department, responsible for the maintenance programming and availability of aircraft, has its offices in this hangar. How aircraft are provided when difficulties arise is demonstrated in the following scenes.
Yes, right. Can you hold on a second? John, we've got an aeroplane coming down from Darwin on a 3-engine ferry.
Do they want just the engine?
Yeah, they'll want an engine change when they get here.
I'll organise a pool spare for them.
Yes, you want a charter? About 1,500. Yes, we can accomplish that. Okay, pick up the passengers. Right, okay, fine.
What are they?
Right, they want a charter at 1,500 to go to Darwin and pick up the passengers from this aircraft. We can send BAF up to Darwin.
How about this out?
Yeah, that one's out. The trainer will return about 1,300 and return around for the 1,900 service tonight.
You have to close up this maintenance here.
Yeah, for sure.
You got the engine right?
Yes, the engine's right. The fuel's spinning.
You call me, I'll have to close this one up.
I'll pass this information on to them down now.
Okay,
Right, I'll go that way, you call me.
The decision is relayed to the maintenance supervisor at Hangar 131, who adjusts his schedule accordingly.
Hello? Yes? Yes? What time are you going to record the trailer? Good. You dropping the price, Judge, eh? All right, we'll fix that. Thank you. Derek?
Yes, Derek.
Although repercussions are felt along the line, solutions are usually found to have aircraft available when they are needed. Flight 580 would have had its flight plan approved by the Department of Civil Aviation and departed the Sydney area in accordance with the air traffic control procedures. Having completed a 1-hour transit at Fiji, the flight is now approaching Faa International Airport at Tahiti. This is the first of 4 complete technical crew changes required for this particular flight, which flies from Sydney through to London, England. The island of Tahiti is administered by the government of France, and here the official language is French.
Tahiti approach, Qantas 580, requesting let down for straighten approach onto runway 04.
Qantas 580.
Although the official language here is French, air traffic controllers are also able to communicate with pilots in English if necessary. Air crew members will always give careful attention to their air-ground communications when flying international routes.
Anti-skid.
On in 4 hours.
Flaps next call.
That's 25.
While passengers are being offloaded at Tahiti and others join the flight for its onward journey, a new technical crew takes over. Far from leaving the crew to resolve their own problems, the progress of this flight, as with all flights, is continually monitored back in Sydney by the Flight Control Center. When an interruption in service requires a delay of several hours, a decision has to be made whether passengers should be booked onward with other airlines, accommodated in hotels, or whether aircraft can be rerouted or chartered to take over the disrupted service. Although most decisions would be taken only after consultation with the technical departments concerned with the type of difficulties encountered, the responsibility to take action is the function of flight control. We might have a look at this activity in Sydney, and here we have the Flight Control Center. Officers on watch keep a 24-hour vigil, ready to make decisions which, for the most part, represent many thousands of dollars to the airline. In order to visualize the progress being made by various flights on different routes, a ready reference is provided by the Flight Progress Board. Alongside the flight number, the letters SYD stand for Sydney and NAN for Nandi. The space between Sydney and Nandi represents the flying time, while the width of the blue card, the transit time. Markers can be added to indicate, as for example with red, that an aerodrome has suspended operations due to fog. Much of the resulting activity is routine, such as updating of flight progress logs. The log provides the precise record of all scheduled details of every flight from which operation statistics can be compiled. The information includes departure times, arrival times, transit times, and if there are delays, reasons for the delay. A second flight crew brings 580 from Tahiti to Acapulco, a distance of 3,551 miles. A 1-hour transit at Acapulco was made, where passengers were cleared through Mexican immigration. And we now join the flight on its way to Mexico City.
We have a problem with number 1 engine, Captain.
What is the problem?
The oil quantity is dropping and the oil pressure is also dropping.
Oil temperature?
Slightly high. Oil quantity continued to drop.
Roger, confirm number 1 engine will shut down. Thrust lever?
Thrust lever's idle.
Start lever?
Start lever's off.
Potential AC?
Checked on number 3.
Yaw damper?
Lever's on, the green light's on.
Phase 2. Checklist and call Mexico Control.
Mexico City, this is Qantas 580. Qantas 580. Reporting a loss in oil quantity and a drop in oil pressure on our number 1 engine. We have closed down our number 1 engine and request engineering to stand by on arrival at Mexico City.
Roger, Qantas 580.
The message taken by this operator at Mexico is relayed through Aeronavis de Mexico, with whom Qantas has an arrangement for the handling of its air-to-ground communications. Aeronavis passes the message on to the Qantas office, where it is taken by the traffic manager.
¿Qantas Airways? Sí. ¿Cómo? Ajá. Esto es. Un momento, por favor, ¿eh? Say, Jim.
The station engineer, seated alongside, is awaiting the arrival of this flight and is advised of the nature of the malfunction. And so, 580, loaded with passengers, cargo, and reserve fuel, is, in fact, making a landing with number 1 engine shut down. While the risk is slight, nevertheless, a great deal of organization is required to be ready for any emergency. Interpretation is sometimes required between the airline and Spanish-speaking maintenance personnel, which adds to the difficulties encountered at such a time. The Qantas engineer determines the difficulty to be a broken seal on an external oil line, and with the aid of American Airlines mechanics, one more of the many such cooperative arrangements, repair work is undertaken immediately. Although transit times at Nassau and Bermuda are already of short duration, the aircraft turnaround time in London is sufficient to re-establish the schedule, although there may be other difficulties to overcome.